Okay, today we're going to look at Lesson 3, and your I can statement or learning objective is I can factor special case expressions. So we're still factoring, still staying along that same line. We're just going to look at some special cases today where there are a couple shortcuts. In this assignment on Math Excel, you will have some problems from Lessons 1 and 2, so that's factoring out the GCF, factoring by grouping, and then just factoring a quadratic expression. So you can use the star method, guess and check, or factor by grouping. Okay, so this assignment is not just special cases. You will have some problems from those other lessons. Today, even though we're factoring a different way, always check for the greatest common factor first. Look at the whole expression and see if you can pull out any greatest common factor before you move on. As usual, I'm going to go faster in the video than I would in person, so remember you can pause and go back and watch it at your own pace, and then use your notes and examples that you do here in your Math Excel Homework 3. First, we're going to look at the difference of two squares. And so that says if you have the quantity a squared minus b squared, you can factor that into a minus b times a plus b. And that goes the other way too. If you have a binomial like this, or two binomials like this that you're multiplying, you can go straight to this answer. It's like a shortcut. Okay? So, and that works because if you have a times a, it's a squared. Negative b times b is negative b squared. And if you have negative ba plus ab, those cancel each other out. So this is just a little shortcut. But if you were to work it out the long way, you would still get the same answer. Okay, so we're just going to look at some examples here. So, number 1, we have x squared minus 49. So we know we're going to have two binomials. We don't have a GCF, so we can go straight here. The square root of x squared is x. Or you can think, what times itself gives us x squared? Well, it's x times x. What's the square root of 49? 7. And to get a negative, we have to have one positive and one negative. And that's it. There's the answer. All right, so that's all we're doing. So number 2, what's the square root of 16? It's 4. What times itself gives us y squared? It's y. The square root of 81 is 9. And we need one positive and one negative. Okay, number 3. Number 3 is a little bit different. We do have a GCF. What is it? It's 5. And so we pull out a 5 and we're left with 9 minus x squared. Okay, so we do the same thing as before. So the square root of 9 is 3. X times x will give us x squared, and we need a positive and a negative. Okay. Number 4 is also a little bit different because we have x to the 4th. Okay, but we're still going to do it the same way. The square root of 4 is 2. What times itself gives us x to the 4th? It's x squared. The square root of 9 is 3. And again, we need a positive and a negative. So basically, you should see the two factors are exactly the same, just one has a positive and one has a negative. All right, and last, number 5, we do have a GCF. It's 6. What times itself gives us x squared? That's x. What times itself gives us y squared is y. And we need a plus and a minus. Okay, and there I realized I skipped a step. So if you need that middle step, it's 6 times the quantity x squared minus y squared. And then we went to that. Next, we're going to look at the square of a binomial. So that's when you take a binomial, has two terms, and you square it. And when you do that, you can quickly go to the multiplied version by doing a squared plus 2ab plus b squared. Okay, and the same is true if you go backwards. If you see something and this first term is squared, the last term is a perfect square, and you see that the middle is 2 times whatever a times b is, you can quickly go to the two factors. However, you do not have to do it this way. You can do it the long way. You can factor it using the star method, guess and check, or by grouping, and you can still end up with the two correct factors. Okay. The important thing is that you see that the two factors are identical. So we will look at some examples. Okay, so here are our 4 examples. So if you notice, on each one, the first term and the last term are perfect squares. Okay, and so if you see that, a light bulb should come on, a red flag, something to let you know, hey, this could be a special case. This could be a square of a binomial. So x squared, if I break that up, is x times x. The square root of 25 is 5. And everything's positive, so they're both positive. And so I know that this works because x times x is x squared. 5 times 5 is 25. And my middle terms will be 5x and 5x, and that does give me 10x. This can also be written as x plus 5 squared. Okay. Now, in Math Excel, I'm not 100% sure which one it wants. You know that Math Excel can be picky sometimes, but either of those mean the same thing. So if you were taking a test and you typed in this, but Math Excel wanted this, I would still give you credit for it, or vice versa. Okay. So number 2, they're both perfect squares. I know the square root of 16 is 4, and I know that 2 times 4 is 8. So this one's going to work as well. I can do x plus 4 and x plus 4, which is the same as x plus 4 quantity squared. Okay. Here, again, perfect squares. This time, the square root of 9 is 3, and we have our x. The square root of 16 is 4. And this time, it's negative. So that means our two factors are going to be negative, because I have to add to get a negative number, but multiply to get a positive. Okay, or again, this is the same as 3x minus 4, the quantity squared. And our last one is the same thing. The square root of 25 is 5. The square root of x squared is x. The square root of 4 is 2. And we'll have that in both. And it's multiply to get a positive, add to get a negative. So we'll throw some subtraction signs in there. And again, that's the same as having the quantity 5x minus 2 squared. All right, so going from this to the multiplied version, you will likely see that. You'll see that on the ACT. You need to recognize that. But going backwards, if this doesn't like ring a bell when you look at it and you don't think, oh, those two factors are going to be the same, it's okay. You can still factor it the normal way and get the right answer. All right, so use this video to help you with your problems in Math Excel on homework 3. Remember, you do have some problems from previous lessons on there, so don't forget about factoring out the GCF or factoring by grouping or just regular factoring a quadratic expression, okay? If you have any questions, hop back in the Google Meet, send me an email, or hit the Ask My Instructor button. Have a great rest of the day.